In this video we are going to discuss types of control systems. So, here we are having 6 basic types of control systems. Those are linear, non-linear, time variant, time invariant, linear time invariant, linear time variant. You can see the list here: linear, non-linear, time variant, time invariant, linear time invariant, linear time invariant and linear time variant systems. So, here we are having these 6 types of control systems. Coming to linear system, if the control system is a linear control system, when we can say a control system is linear means whenever the control system obeys homogeneity and linearity, then only we can say that is linear system. That means, so overall response of the system is equivalent to individual response of the system. Coming to non-linear system, if the control system is not going to obey the linearity and homogeneity, then we can say that is non-linear system. It's violating homogeneity and linearity means that is non-linear system. Coming to time variant system, if output is varying with time, so that is time variant system. If output is not having any variance in time, that means with time the output is not going to vary. So, that is called as time invariant system. Coming to linear time variant system, if the control system is both linear and time variant, so then we can say that system is linear time variant system. So, coming to linear time invariant system, if the system is both linear and time invariant, then we can say that is linear time invariant control system. That means this is LTV and this is LTI control system. So, coming to linearity, for example, if you are giving any signal x1 of t, so the gain is a1 of t. So, here you are getting some y1 of t. So, this y1 of t is equivalent to, so I am considering like a1, so this is the gain of that line. So, y1 of t is equivalent to a1 x1 of t. So, the output y1 of t by passing through this element is equivalent to a1 x1 of t. So, now similarly another signal x2 of t is there. So, we are taking that. So, here this is equivalent to a2 and here we are having another output y2. y2 is equivalent to a2 x2 of t. And I am doing like this. So, I am taking x1 of t with a1 and x2 of t with the a2. So, I am adding these two by using a summer. So, here I am taking this line output as y3 of t. So, now here the output is a1 x1 of t plus a2 x2 of t. So, same output we are giving here, that means a1 x1 of t plus a2 x2 of t. If you consider individually, this y3 of t is equivalent to, this is common output is equivalent to individual output addition y1 of t plus y2 of t. You can see y3 of t is equivalent to a1 x1 of t plus a2 x2 of t. So, here when you consider y3 of t, so this is equivalent to y1 of t plus y2 of t. So, this is called as linearity. If you are taking another element here, then this y3 of t is going to change. You are going to get another value which is not equivalent to y1 of t plus y2 of t. So, then the system is not linear system, non-linear system. Now, the system is linear. For example, here if you included a3, then your a3 is, then your y3 of t is equivalent to a1 a3 x1 of t plus a2 a3 x2 of t, that is not equivalent to y1 of t plus y2 of t. In that case, we can say that system is non-linear system, but in this case the system is a linear system. So, in the next class we will discuss about feedback of control system.